Welcome to the discussion today. Today we are looking at Form 3 Chemistry under the topic gas laws. In Form 1 we talked about matter and we said matter exists in three states, namely solid, liquid and gas. We know that all gases are made up of tiny particles known as molecules, and these gas molecules are far apart and move randomly in all directions because they possess kinetic energy. In this topic, we shall discuss the relationship between pressure, temperature, and volume of gases under three laws, namely Boyle's law, Charles' law, and combined gas law. Let us begin by looking at Boyle's law. And Boyle's law states that the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. Mathematically, the volume of a given mass of a gas varies inversely as its pressure. In this case, we can say volume will be equal to, instead of now 1, we introduce K, which is a constant of variation, over the pressure. If you multiply by P on both sides, we are going to have the following. If volume is equal to K divided by P, if you multiply by pressure on both sides, pressure and pressure will cancel, and therefore if you take pressure times volume, it must be able to give you a constant K, and this constant simply means the constant of variation. If the volume of a gas changes from V1 to V2, then pressure must also change from pressure 1 to pressure 2, giving us the following relationship. That is, pressure 1 multiplied by volume 1 must always give us pressure 2 multiplied by volume 2, which is equal to a constant K, and this constant is a constant of variation. Let us look at the applications of Boyle's law, and the applications are mainly in form of calculations. The first question we have reads, a sample of ammonia gas occupies 670 centimeter cubic at a pressure of 850 millimeter mercury. From this question, a sample of ammonia gas occupies a volume, that is V1, of 670 centimeter cubic at a pressure, this is pressure 1, which is 850 millimeter mercury. What will be the volume of the gas? What will be the volume, that is V2, if the pressure, that is pressure 2, is reduced to 380 millimeter mercury? We know, according to Boyle's law, pressure 1, volume 1 must give us pressure 2, volume 2. Our pressure 1 is 850. We multiply by volume 1, which is 670, and this one will give us pressure 2 of 380. We multiply by volume 2, which is the quantity we are looking for. If you want to get volume 2, we divide both sides by 380. 380 and 380 will cancel, giving us volume 2, and volume 2 will be equal to 850 multiplied by 670. You divide by 380, and this gives us 1453.95 centimeter cubic as the answer to this particular question. Let us look at another example. Example 2. A volume of 375 centimeter cubic of a gas has a pressure of 20 atmospheres. What will be its volume if pressure is reduced to 15 atmospheres? The first thing we need to do is to identify the given variables. We have volume 1 of 375 centimeter cubic and a pressure, that is P1, of 20 atmospheres. What will be its volume? Since we have volume 1, volume 2 is missing, and the pressure 2 has been given as 15 atmospheres. Remember, according to Boyle's law, pressure 1 volume 1 will give us pressure 2 volume 2. Pressure 1 has been given as 20. We multiply by volume 1 of 375, and this will give us pressure 2, which is 15, multiplied by volume 2, which is what we are looking for. From there, we divide by 15 on both sides. 15 and 15 will cancel, so that we remain with volume 2, and volume 2 will be equal to 20. You multiply by 375, everything divided by 15, and this one will give us 500 centimeter cubic as volume 2. We move down to example number 3, or question number 3. A sample of nitrogen gas occupies a volume of 180 centimeter cubic at a pressure of 800 kilopascals. What will be the pressure at the volume of 340 centimeter cubic at a constant temperature? We have been given pressure 1 as 800 kilopascals, and also a volume 1 of 180 centimeter cubic. What will be the pressure, that is pressure 2, that is missing, at a volume, that is V2, of 340 centimeter cubic? Remember, pressure is inversely proportional to volume. That means if volume increases, pressure reduces, and vice versa. According to Boyle's, pressure 1 volume 1 must give us pressure 2 volume 2. Pressure 1 has been given as 800. We multiply by volume 1 of 180, and this one will give us pressure 2, which we don't have. We multiply by volume 2 of 340. If we divide by 340 on both sides, 340 and 340 will cancel, so that we remain with pressure 2, and pressure 2 will be equal to 800. You multiply by 180, everything divided by 340, and this will give us 423.53 kilopascals as our pressure 2. We move down to the second law, which explains the behavior of gases under different conditions of temperature, volume, and pressure, which is Charles' law. And according to Charles' law, The volume of a given mass of a gas is directly proportional to its absolute temperature when pressure is kept constant. Mathematically, we say that volume is directly proportional to temperature at constant pressure. That means pressure does not change. In this case, we can move down and say volume will be equal to, we introduce a constant of variation, then T. If you want to make the constant the subject, you divide by T on both sides, where T and T cancels, and therefore we say volume over temperature will always be equal to a constant. If the volume of a given mass of a gas changes from V1 to V2, then its temperature will also change from temperature 1 to temperature 2, giving us the following equation. That is, if you take volume 1, you divide by temperature 1, this must give us volume 2 over temperature 2, and this must always give us a constant of variation, which is K. Under Charles' law, temperature must always be converted to the absolute scale, and the absolute scale is always in kelvins, and we do this by adding 273 to any temperature given in degrees Celsius. So let us look at the application part of this Charles' law, and application is in form of calculations. The question we have reads, the volume of a gas at 72 degrees Celsius is 360 centimeter cubic. What will be its volume at 160 degrees Celsius? Remember, when temperature is given in degrees Celsius, it must be converted into kelvins by adding 273. We have been given temperature 1 of 72. We convert it into kelvins by adding 273, and this gives us 345 kelvins under a volume 1 of 360 centimeter cubic. What would be its volume? Volume 2 is not given, but we have been given temperature 2 of 160 degrees Celsius converted into kelvins by adding 273, which gives us 433 kelvins. According to Charles' law, we know volume 1 over temperature 1 will give us volume 2 over temperature 2. From here we substitute. Volume 1 is 360. We divide by temperature 1 over 345, and this will give us volume 2, which is not provided. We divide by T2, and our temperature 2 is 433. If you cross multiply, we are going to have V2 multiplied by 345, giving us 345 V2, and this will give us 360 multiplied by 433. If you divide both sides by 345, you'll get V2 being equal to 451, being equal to 451.83 centimeter cubic as the volume that we are looking for. We move to question number 2 under Charles' law, and the question we have reads, a gas occupies 450 centimeter cubic at a temperature of 27 degrees Celsius. What volume would the gas occupy at 177 degrees Celsius if pressure remains constant? Volume 1 is equal to 450 centimeter cubic, and our temperature 1 is 227 degrees Celsius converted to kelvins by adding 273, and this one gives us 300 kelvins. At what volume would the gas occupy? Volume 2 has not been given, but temperature 2 has been given to be 177. We convert it to kelvins by adding 273, and this gives us 450 kelvins. We know that according to Charles' law, volume 1 over temperature 1 will give us volume 2 over temperature 2. We can substitute. Volume 1 is 450. We divide by temperature 1, which is 300, and this one will give us volume 2, which we don't have. We divide by our temperature 2 of 4, our temperature 2, which is 450. If you cross multiply, we are going to have 300 times volume 2, which gives us 300 V2 being equal to 450 multiplied by 450. You divide by 300 on both sides. 300 and 300 will cancel, leaving us with volume 2, and volume 2 will be equal to 450 multiplied by 450 divided by 300, which gives us 675 centimeter cubic as the answer to question number 2 under Charles' law. We go to question number 3. At a temperature of 57 degrees Celsius, nitrogen gas occupies a volume of 750 centimeter cubic. At what temperature will the gas occupy 100 centimeter cubic? Express the answer in degrees Celsius. The first thing we need to do is to identify the variables we have, and in this case we have our temperature 1 of 57. We add 273, which gives us 330 kelvins. We have a volume, that is volume 1 of 750 centimeter cubic. At what temperature? We already have T1, T2 is missing, and the volume 2 has been given as 100 centimeter cubic. According to Charles' law, V1 over T1 will give us volume 2 over temperature 2. Volume 1 is 750 divided by temperature 1 of 330, and this one will give us volume 2, which is 100 divided by temperature 2. If we cross multiply, T2 times 750 will give us 750 T2, and this one will give us 330 you multiply by 100. If you divide both sides by 750, 750 and 750 will cancel, giving us our temperature 2 being equal to 44 kelvins. But remember, the question is asking us to calculate temperature in degrees Celsius. In degrees Celsius, we take temperature in kelvins, we minus 273, and this one will give us negative 229 degrees Celsius as the answer to this particular question. The last thing we are going to look at for today, it is combined gas law, and the combined gas law combines both Charles and Boyle's law. Remember, we have Charles' law. Before we look at the solution to this question, we have Charles' law, and Charles' law states that volume 1 over temperature 1 will give us volume 2 over temperature 2. We also have Boyle's law, which states that pressure 1 multiplied by volume 1 will give us pressure 2 multiplied by volume 2. We can combine the two to give us the following equation, that is pressure 1, volume 1 because it is common. We divide by temperature 1, this will give us pressure 2, volume 2 is common, so we pick 1 divided by temperature 2. This is when we combine both Boyle's and Charles' law. Let us apply this formula in the application part under a calculation question. And the question we have reads, a gas occupies a volume of 196 centimeter cubic at 25 degrees Celsius. We have volume 1 of 196 centimeter cubic, and the temperature we have is 25 degrees Celsius, our T1. So if you take 25 plus 273, this one will give us 3. This one will give us no, this is 298 kelvins. We also have a pressure, that is pressure 1 of 680 millimeter mercury. State the volume it will occupy, that is volume 2, which we have not been given, and the temperature has been reduced to negative 37 degrees Celsius. So our temperature 2 is going to be negative 37. We add 273, giving us 236, kelvins. Now we go and substitute the variables we have back into the formula. We have pressure 1 of 680. We multiply by volume 1, which is 196. We divide by our temperature 1, and our temperature 1 is going to be 298, and this one will be equal to pressure 2, and our pressure 2 is 650. We multiply by volume 2, we divide by temperature 2, and our temperature 2 is 236 kelvins. If you cross multiply, we are going to have V2 being equal to 680. We multiply by 106, we multiply by 236, we divide by This is 200.